further example in this video. So this is what I like about this question here is it just kind of tells you where you might need this kind of thing. So this is kind of from curve fitting. Remember you had simultaneous equations and usually it was in two unknowns, but if you want a more complicated curve fitting thing, taking into account more variables, you might need to solve equations in four unknowns, something like this. Okay, so we want to do elementary row operations until we get something looking like this. 1 zeros underneath, 1 zeros underneath, 1 zeros underneath. And we get this staircase. And once we make these ones, they will be used to kill whatever happens to be underneath. So that's essentially the Gaussian elimination algorithm. Okay, so we're going to write this in augmented form and get it in this form eventually. Okay, so if I write this, I call this in the augmented form. So I have 1a, 2b, 3c, 1d equal to 6, 2a, 7b, 7c, 3d equal to 0, 3a, 9b, 8c, 6d equal to 0, and finally 4a, 5b, 3c, 7d equal to 0. Now, if you were having an exam, it would be completely necessary, even if you kind of got the method quite easily already and understood that you could check your answers, by the way, by substituting all your answers into the equation. If you're doing an exam, I'd be recommending doing a lot of practice of this because it's very easy just to make silly mistakes. Okay. Don't tell me that's all the space I have. No, it's not. Okay. So I have a pivot here already. That's great. Now I'm going to use that pivot to kill the 2, 3, 4 underneath. So I'm going to do row 2 sent to itself minus twice row 1. I'm going to do row 3 sent to itself minus 3 times row 1. And I'm going to do row 4 sent to itself minus 4 times row 1. All the time using what's called the pivot row for this column, which is the first row, to kill the things underneath. So first row is done for all time. 1, 2, and after we kill the things in the first column, we're never going to use the first row again until we're getting the solutions. So I'm going to go across row 2 sent to itself minus twice row 1. So 2 minus 2 times 1 is equal to 0. 7 minus 2 times 2 is equal to 3, isn't it? 7 minus 2 times 3 is equal to 1. And 3 minus 2 times 1 is equal to 1. And 0 minus 2 times 6 is minus 12. Now I'm going to go for the third row. 3 minus 1. 3 minus 3 is 0. 9 minus 6 is 3. 8 minus 9 is minus 1. 6 minus 3 is 3. And 0 minus 18 is minus 18. I'm going quicker there than I normally would in class, but this is the beauty of the offline. You can pause me and kind of go through it yourself in your own speed. The bottom row then is 4 minus 4 is equal to 0. 5 minus 8 is equal to minus 3. Isn't it? Yeah. 3 minus 12 is minus 9. And 7 minus 4 is 3. And 0 minus 24 is minus 24. Okay. Happy days with a pivot and zeros underneath. The next thing we're going to attack is this 3 and turn it into a 1. Now, if it happened that one of these was in fact a 1, I could swap row 2 with it, and that would be an alternative way of getting a pivot in column 2. Now, I usually won't do it. I'll usually do it the kind of like a machine. So we're going to do row 2 sent to itself divided by 3. And now we are going to have fractions, and we must be comfortable using them. We can't do rounding. We've learned already that that's just not going to work. So first row is 1, 2, 3, 1, 6. And now we're doing row 2 divided by 3. 0 divided by 3 is 0. 3 divided by 3 is 1. 1 divided by 3 is 1/3. And 1 divided by 3 is 1/3. and minus 12 divided by 3 is minus 4. Okay, now we're going to try and kill those, the 3 and the minus 3. Now the smart thing to do here actually would be to do row 3, take away the old row 2, and row 4 plus the old row 2, but I'm always going to do it the same way. I'm always going to use the pivot. So I'm going to do, instead of that smart way, I'm going to kind of do the dumb way. Row 3 is sent to itself minus 3 times the new row 1, and I put a dash just to communicate to myself that I'm using this new row 1 over here. And similarly, row 4 is sent to itself plus 3 times the new row 1. Okay, off we go now. So I could just do it here, but I'm going to use this one. So 0 minus 3 times 0 is 0. 3 minus 3 times 1 is 0. Minus 1 minus 3 times a third is minus 1. Minus 1 is minus 2. And 3 minus 3 times a third is 3 minus 1, which is 2. And finally, minus 18. Now this is where you want to be careful with your signs. You can use the calculator. I mean, I'm a bit tired. I had another bad night. Minus 18 minus 3 times minus 4. No shame in it. Well, okay. So now the last one then, row 4 sent to itself plus 3 times new row 1. So 0 plus 3 times 0 is 0. Minus 3 plus 3 times 1 is 0. Minus 9 plus 3 times a third is minus 9 plus 1, which is minus 8. And then 3 plus 3 times a third is 3 plus 1 is 4. And the last one, I'll use the calculator, minus 24 plus 3 times minus 4. And I get minus 36. I'm going to double check that there for myself. Yeah, looks good. So hopefully I don't make any stupid mistakes here. So I'm just going to check my answer by working off this. So 3 minus 3 is 0. Yeah. And then adding these, yeah. So unless I've made some other stupid mistake, we should be fine. So we have pivot, and now we want to make a pivot out of this. So we're going to divide row 3 by minus 2. So we're going to do row 3 divided by minus 2. Okay, so first row, 1, 2, 3, 1, 6. Second row done for all time, 0, 1, 1/3, 1/3, minus 4, and now we're doing row 2 divided by minus 2. So 0 divided by minus 2 is 0, 0 divided by minus 2 is 0, minus 2 divided by minus 2 is 1, getting that pivot, 2 divided by minus 2 is minus 1, and minus 6 divided by minus 2 is 3. And now we want to use that new pivot to kill the minus 8 underneath. And we can do that by doing row 4 is sent to itself. I want to add 8, so I do plus 8, which isn't a row operation. But if I use this pivot, I can do it. Multiply by essentially 1. So I get 0 plus 8 times 0 is 0. 0 plus 8 times 0 is 0. Minus 8 plus 8 times 1 is 0. 4 plus 8 times minus 1 is 4 minus 8 is minus 4. And finally, minus 36 plus 8 times 3 is minus 36 plus 24, which is minus 12. Now I just have to fix the very last thing. So I think there's actually way more room here on the next page. Okay, which isn't ideal, but anyway, it'd be nice to see lots of room here. Okay, so what I'm going to do, can I memorize this? I'm going to pause it and just write it down. So what I've just done is I've written down the augmented matrix off screen. Big waste of space here, obviously, my bad. But all that remains to do to it is to turn the minus 4 into a 1 to get a pivot. Now, you might realize you don't have to draw the whole shoot and match every time, but I'll let you figure that out yourselves. I want to turn this minus 4 into a 1. So what I do is I do row 4 send to itself divided by minus 4. Now this seems kind of tricky and stuff, but imagine trying to solve a 4x4 system on your own. This really organizes it very well. So what I end up with, so if I write the rest of the thing, do it nice and big here. So I get 1, 2, 3, 1, 6, 0, 1, 1/3, 1/3 minus 4, 0, 0, 1, minus 1, 3, and then if I do the final row divided by minus 4, I get 0, 0, 0, 1, 3. Now we'll analyze it. So let's look at the pivots. Well, actually, first really we should look are there solutions, because if you look at the pivots, you might be writing down there's parameters when there's no solution. Look, there's no row of the form 0, 0, 0, non-zero, so there are solutions. Now we can have a look at the pivots. There is a pivot here, 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 and I think the variables were A, B, C, D. So A has a pivot, B is a pivot, C is a pivot, D is a pivot, so there are no parameters. And that means there is no variable that can take on infinitely many values. So that means there's a unique solution. D equal to something, C equal to something, etc. So the bottom row there reads, now we'll probably do it here. D is equal, so it's, look at it, it's 0A plus 0B plus 0C plus 1D equal to 3. In other words, 1D is equal to 3. Now I'll go a little bit quicker on the C. So now you can take your time. So what you can do is say write down the second last row as C minus D is equal to 3. And then either you put the D in now and solve, or solve for C and then put in the D. Maybe you put in the D at this point. And then you add 3 to both sides, C is equal to 6. Now, if you need to take your time like that, personally, I think if you do enough tutorial, put enough tutorial time in, you'll be able to just look at this row here and realize it is what it is, C minus D equal to 3. So you can just write C is equal to 3, and then that's a minus D, so you add it to both sides, plus D, but you know that D is equal to 3. So you get 6. It'll just be a quicker way of doing it as such. Now you want to be careful, but it should be okay. Then similarly with B, so it's B plus the third C plus the third D equal to minus 4. So B is equal to minus 4, and you want to take away a third C and a third D from both sides. I shouldn't even have put those in. And then I can put this all in the calculator. So minus 4, probably don't even need the calculator. Minus a third C is minus 2, minus a third D is 1. So I get minus 7. And then finally A, so it'll be 6, take away 2B, which should be minus 14. Take away 3C, so that'll be minus 3 times 6. And then take away D. So I'm saying if you're a bit confused by that, take your time like this. So what do we get there? 6, we get 20, minus 18 is 2, minus 3 is minus 1. So we get our 3 solutions like that. So we've done a few examples. That's basically it. There's 3 scenarios: unique solution, infinitely many solutions with a parameter, which we've seen a little of, but we'll see a bit more of now in the next set of lectures. And the other possibility is no solutions.